An IP address represents a unique address that distinguishes any device on the internet or any network from another. IP or Internet Protocol defines the set of commands directing the setup of data transferred through the internet or any other local network. An IP address is represented by a series of numbers segregated by periods. They are expressed in the form of 4 pairs. An example address might be 255, 255, 255, 255, wherein each set can range from 0 to 255. Here are some examples given for representation of IP addresses. There are 2 versions of IP address. Internet Protocol version 4 was the initial version, which is still widely used by most of the websites on the internet. It has a size of 32 bits and holds 232 numbers equals to 4,294,967,296. The depletion of numbers on IPv4 forced authorities to introduce another Internet Protocol version 6. The IPv6 is still not widely used due to compatibility with all network devices. It supports the size of 128 bits and holds 2128 numbers equals to 3,403 times 1038. Furthermore, there are different categories of IP addresses known as public IP address, private IP address, dynamic IP address, and static IP address, whereas the 2 standards for IP addresses are IP version 4 and IP version 6. In this video, we are going to discuss IPv4 only. There are following 5 classes of IPv4 address. We'll discuss all classes in detail. The first bit of the first octet is always set to 0. Thus, the first octet ranges from 1 to 127, that is, class addresses only include IP starting from 1.x.x.x to 126.x.x.x only. The IP range 127.x.x.x is reserved for loopback IP addresses. The default subnet mask for class A IP address is 255.0.0.0, which implies that class A addressing can have 126 networks and 16,777,214 hosts. An IP address which belongs to class B has the first 2 bits in the first octet set to 10. That is, class B IP addresses range from 128.0.x.x to 191.255.x.x. The default subnet mask for class B is 255.255.x.x. Class B has 16,384 network addresses and 65,534 host addresses. The first octet of class C IP address has its first 3 bits set to 110. That is, class C IP addresses range from 192.0.0.x to 223.155.155.x. The default subnet mask for class C is 255.155.155.x. Class C gives 2,097,152 network addresses and 254 host addresses. Very first 4 bits of the first octet in Class D IP addresses are set to 1110, giving a range of. Class D has IP address range from 224.0.0.0 to 239.255.255.255. Class D is reserved for multicasting. In multicasting, data is not destined for a particular host. That is why there is no need to extract host address from the IP address, and Class D does not have any subnet mask. This IP class is reserved for experimental purposes only for research and development or study. IP addresses in this class ranges from 240.0.0.0 to 255.255.255.254. Like Class D, this Class 2 is not equipped with any subnet mask. Internet Protocol version 4 divided into 2 categories, that's are public IP addresses and private IP addresses. Public IP addresses. The public address is also known as an external address as they are grouped under the WAN addresses. We can also define the public address as a way to communicate outside the network. This address is used to access the internet. The public address available on our computer provides the remote access to our computer. With the help of a public address, we can set up the home server to access the internet. This address is generally assigned by the ISP. In order to communicate with the outside world, these IP addresses must have to be translated to some public IP addresses using NAT process or web proxy server can be used. The sole purpose to create a separate range of private addresses is to control assignment of already limited IPv4 address pool. By using a private address range within LAN, the requirement of IPv4 addresses has globally decreased significantly. It has also helped delaying the IPv4 address exhaustion. IP class, while using private address range, can be chosen as per the size and requirement of the organization. Larger organizations may choose Class A private IP address range, where smaller organizations may opt for Class C. These IP addresses can be further subnetted and assigned to departments within an organization. Private IP addresses. Every class of public IP addresses has some addresses reserved as private IP addresses. These IPs can be used within a network, campus, company, and are private to it. These addresses cannot be routed on the internet, so packets containing these private addresses are dropped by the routers. Here are the schemes of IP addresses from the first three classes reserved for private addressing. In order to communicate with the outside world, these IP addresses must have to be translated to some public IP addresses using NAT process or web proxy server can be used. The sole purpose to create a separate range of private addresses is to control assignment of already limited IPv4 address pool. By using a private address range within LAN, the requirement of IPv4 addresses has globally decreased significantly. It has also helped delaying the IPv4 address exhaustion. IP class, while using private address range, can be chosen as per the size and requirement of the organization. Larger organizations may choose Class A private IP address range, where smaller organizations may opt for Class C. These IP addresses can be further subnetted and assigned to departments within an organization. Here are some other schemes reserved for loopback checking and link local addressing by the Internet Assigned Numbers Authority. Loopback IP addresses. The IP address range 127.0.0.0 to 127.255.255.255 is reserved for loopback. That is, a host's self-address, also known as localhost address. This loopback IP address is managed entirely by and within the operating system. Loopback addresses enable the server and client processes on a single system to communicate with each other. When a process creates a packet with destination address as loopback address, the operating system loops it back to itself without having any interference of NIC. Data sent on loopback is forwarded by the operating system to a virtual network interface within operating system. This address is mostly used for testing purposes like client-server architecture on a single machine. Other than that, if a host machine can successfully ping 127.0.0.1 or any IP from loopback range, implies that the TCP/IP software stack on the machine is successfully loaded and working. Link local addresses. In case a host is not able to acquire an IP address from the DHCP server and it has not been assigned any IP address manually, the host can assign itself an IP address from a range of reserved link local addresses. Link local address ranges from 169.254.0.0 to 169.254.255.255. Assume a network segment where all systems are configured to acquire IP addresses from a DHCP server connected to the same network segment. If the DHCP server is not available, no host on the segment will be able to communicate to any other. Windows and Mac OS supports this functionality of self-configuration of link local IP address. In absence of DHCP server, every host machine randomly chooses an IP address from the above-mentioned range and then checks to ascertain by means of ARP if some other host also has not configured itself with the same IP address. Once all hosts are using link local addresses of same range, they can communicate with each other. In the next video we'll discuss about subnetting of IP address.